Hi YouTube, Tim Unker here. In this video, we're going to keep covering the Algebra 2 Finals review. So we're up to problem 24. What is the sum of all odd numbers from 0 to 350? So the sum formula is going to be the sum of n numbers equals the number of terms. So sum of n terms equals the number of terms divided by 2 times the first term, which we can indicate with a sub 1, plus the last term, which we can indicate with a sub n. Okay, so we can figure out a sub 1 and a sub n pretty easily. Let's start with those. So a sub 1 is going to be the first odd number from 0 to 350. That's going to be 1. A sub n is going to be the last odd number from 0 to 350, which is going to be 349. Okay, but we need to find the number of terms. So one way we can do that is with the explicit definition. So I could say a sub n equals a sub 1 plus n minus 1 times the common difference d. All right, so the common difference d is going to be 2 because there's a difference of 2 between each odd number. So 1, 3, 5, etc. We know a sub n, so 349. That's going to equal 1 plus, we don't know what n is, so we have n minus 1 times our common difference of 2. So we can distribute the 2, we can multiply it by the n, and we can multiply it by the minus 1 here. And we can start to work this out and solve for n. So we get 349 equals 1 plus, we're going to have 2 times n is 2n, minus 2 times 1, which is 2. And we can continue to neaten up the right-hand side here by combining like terms. The 1 plus minus 2 is going to be a minus 1. We fix that n there. So we have 2n minus 1. And that equals 349. And so what should we do to solve for n? We should add 1 to both sides. And we're going to get 350 equals 2n. Then if we divide by 2, well, n is going to be 175. All right, so we're looking for the sum here, the sum of 175 terms. That's going to equal 175 divided by 2 times 1 plus 349. And we can go to Desmos and figure out what this is. So now we're at Desmos, we'll do 175 divided by 2 times 1 plus 349, and that's 30,625. So our sum here of the 175 terms is 30,625. All right, let's keep going. Go down to problem 25. Write the sum of the following arithmetic series in sigma notation with a capital sigma. All right, so we got to figure out the number of terms here. So we can say, we can use our explicit definition to do that. A sub n equals a sub 1, this is the general one, plus n minus 1 times the common difference d. So this negative 9 is a sub 1. A sub n is 33. And the common difference d is 2 because there's a difference of 2 between each number. So we're going to say 33 equals negative 9 plus n minus 1 times 2. Okay, so we'll distribute again. So we'll get -9 plus 2n minus 2. That's equal to 33. If we combine like terms over here, we have 2n minus 11 equals 33. If we add 11 to both sides, so we get 44 equals 2n. So if we divide both sides by 2, we get n equals 22. All right. So our general form for summation notations, we have this uppercase sigma. I know everyone likes that. So uh, we start at n equals 1. We go to whatever n is. And we have the first term a sub 1 plus n minus 1 times common difference d. So that's the form we're going to write. So we're going to create our sigma here, a nice big sigma. We'll say n equals 1. And we have 22 terms, so we go to 22, as we found that right here. And our first term is -9 plus, and we have n minus 1 times our common difference, which is 2. And there we go. That's our arithmetic series written in summation notation. Okay, I'm going to erase a little bit and we'll move to problem 26. All right, in problem 26, we're finding the common ratio of the following geometric sequence. We can do that simply by dividing a term by the previous term. So the common ratio R, if we take the second term, for instance, and divide by the first term, 12 divided by 4, we get our common ratio of 3. We would have gotten that also if we divided 36 by 12. So our common ratio is 3 in this particular one. All right, let's go down to problem 27. Find the missing term in the following geometric sequence by finding the geometric mean or its opposite. Show your work. Okay, so we are going to take the square root of the product of the two numbers surrounding this. So the geometric mean, which we can abbreviate as GM, that's going to be the square root of 1 times 9, which is just going to be the square root of, well, 1 times 9 is 9. So the geometric mean is going to be 3. So the missing term could be 3 or -3. It would be -3 if the common ratio was negative. Okay. All right. The next one. What is the sum of the following geometric series? So the sum of n terms is going to be the first term, a sub 1, times 1 minus common ratio to the nth power divided by 1 minus the common ratio. Okay, so what do we need to know? We need to know the common ratio, a sub 1, and we need to know the number of terms. So the first term, a sub 1, is going to be 3. That's easy. The common ratio, we can take the second term divided by the first, so 12 divided by 3, that's 4. So we need to know two of those things, but we need to know the explicit, we need to know the nth term, so we need to do the explicit definition, which is going to be a sub n equals a sub 1 times the common ratio r to the n minus 1 power. Okay, so we're going to say 12,288. That's going to equal the first term 3 times the common ratio of 4 to the n minus 1 power. And we'll divide both sides by 3. Okay, so let's divide 12,288 divided by 3, and we get 4,096. So we get 4,096 equals 4 to, because these threes cancel, right? 4 to the n minus 1 power. So we can put 4 to the x minus 1 power equals 4,096, and that'll give us a straight line through what x is here. Okay, so I'm going to do that. So I'm going to say 4 raised to the x minus 1 power equals 4,096. I see that goes right through 7. So my mistake. 4 to the 6th power is 4096, but x is going to be 7, right? 7 minus 1 is 6. Okay. So n has to be 7. Hopefully that makes sense. All right, so now we've got this formula over here. So take stock of this, maybe write this down, pause the video right now, because I'm going to have to erase it, and then we'll go use these numbers here now that I know that n equals 7. Okay, so hopefully you've written that down. Let's erase this stuff. Okay, so we're going to say the sum of the 7 terms equals first term 3 times 1 minus 4 to the 7th power all over 1 minus 4. Let's go to Desmos for that. Okay, put that into Desmos, and we get 16,383. So the sum of the 7 terms here is 16,383. Just check that, make sure. Yep. Okay, so this is my solution here. All right, let's keep going. Let's look at problem 29. Evaluate from n equals 1 to 14 this expression 3 times 2 to the n minus 1 power. So this is the sum from n equals 1 to 14 of this expression. So we need to know the number of terms. Since we start at 1 and we go to 14, there's going to be 14 terms. We need to know the first term, which if we enter in 1 for n, so it's going to be 3 times 2 to the 1 minus 1 power, which is 3 times 2 to the 0 power, which any non-zero number to the 0 power is 1. So this is 3 times 1. So for my first term is 3. And we need to know the common ratio. So every time I increase n, I multiply by 2. So the common ratio here is 2. And now we can say that the sum of the 14 terms equals the first term, 3, times 1 minus common ratio 2 to the 14th power, the number of terms, over 1 minus the common ratio 2. All right, so we'll go to Desmos now, and let's delete all this stuff. Okay, and let's see, what am I doing here? 3, okay, so 3 times 1 minus 2 to the 14th power divided by 1 minus 2, and we get 49,149. And that's our solution for that one. All right, so let's clear out this. All right, this next one, we're starting from n equals 0 to 12. So we have to count the 0. So that's actually going to give us not 12 terms, but 13 terms. Our first term is going to be 4 times negative 5. This time we'll start with n equals 0. So negative 5 to the n power, which is 0. So it's going to be 4 times 1, which is going to be 4. Our common ratio this time is going to be negative 5 because every time we raise the power of n, we multiply by negative 5. All right, so our sum of the 13 terms is going to equal our first term 4 times 1 minus negative 5 to the 13th power divided by 1 minus negative 5. So our sum of our 13 terms is going to equal, well, we'll put this into decimal. So let's see, what was my first term here? 4. Okay. So 4 times 1 minus negative 5 to the 13th power divided by 1 minus negative 5. And we get, let me write that down, 813,802,084. So we have 813,802,084. And that's my solution for that one. All right, problem 31, convert 60 degrees to radians. So 60 degrees, and we're going to multiply by a conversion factor. So there are 180 degrees for every pi radians. I don't know why I wrote an equal sign there. Getting ahead of myself. So the degrees will cancel. Let's make that a little bit bigger. The degrees here will cancel. And we get 60 pi over 180 radians. So we can reduce this. 60 goes into 183 times, so I can cross this out, write a 1, cross this out, write a 3. 1 pi is just pi, so this becomes, our solution becomes pi over 3 radians. Okay, next one, convert 5/3 pi, that should be radians to degrees. So we're going to multiply by pi radians. I'm just going to write rad because I'm going to run out of room. Over 180 degrees, or not pi radians for 180 degrees, rather. Sorry, I misspoke there. All right, so these are going to cancel. We'll multiply across. And we're going to get 5 times 180 degrees divided by 3. 3 goes into 180 60 times, so this is just going to be 5 times 60 divided by 1, which is just 5 times 60. So our solution here is 300 degrees, and make sure you have that degree symbol there. So 300 degrees. All right, last one. 4x minus 10 equals 30. What is the value of 18x? Let's add 10 to both sides. And we get 4x equals 40. Divide by 4. So we get x equals 10. But we're not done yet. We have to do 18 times 10, which is 180. All right, there we go. That's the finals review. Hopefully you found this video helpful. If you did, please like and subscribe.